Is that visible?
Yes, sir. Yes, sir.
Okay. Now, classification and tabulation, right? Now, in the last chapter, we described the various methods of collecting data for an inquiry. And firstly, the data collected in any statistical investigation known as the raw data are so the voluminous and the huge that they are the unwidely and the uncomparable. So having the collected data collected and edited the data, and the next important step is to organize. To present in it the readily comparable condensed form, which will be the important characters of the data. Facilitate comparison and the rendered suitable for the further processing and interpretation. The presentation of the data is broadly classified into the two categories: tabular presentation and diagrammatic or graphic presentation. See, now we have a data, right? We have a huge collection of our data. Now, we have to see, because we have the data, numerous data, huge collection, right? Volume is very high. So it is difficult to get answer from the data or to get calculation from the data. So we have to arrange in such a manner that we can easily process it, or we can apply some tools on it, and so that we can get some useful data or interpretation from that, right? So what we need, we have to arrange the data in good presentable form, right? So we have classified into two ways. One is the tabular, one is the diagrammatic or the graphical presentation. Statistical table in an orderly logically arrangement of data into rows and columns, and it attempts to present the voluminous and the heterogeneous data in condensed and homogeneous form. But before the tabulating the data, generally systematic arrangement of raw data into different homogeneous classes is necessary to sort out the relevant and significant features from the irrelevant insignificant. See what happened. We arrange that data in, first of all, in table. That is called a statistical table. So it is the orderly and logical arrangement of data in rows and columns, and attempts to present in the voluminous and the heterogeneous data in the condensed form or homogeneous form, right? So we have raw data. So we arrange in such a manner in some rows and the column so that huge data, huge volume of data, and heterogeneous means that those we have different categorical heads. So we condensed it and shown or represent in such a manner that we can easily get the information from that, right? The process of arranging the data into the groups or classes according to resemblance in the similarity is technically called classification, right? Process of arranging data into the groups or classes, this is called classification, right? The classification of the data is primarily to its tabulation. So it is the first step of the tabulation, because the item with the similarity must belong together before the data presented in the form of the table. In other hand, the diagrams and the graphs are the pictorial devices present the statistical data. In this chapter, we shall see Classification is what? That we are in the data in groups and classes, right? Groups or classes. This is the first step for the tabulation. Now come to what is the classification. See, classification. Generally, they ask for this is an important topic, classification. The tabulation general ask the question, what is the classification? What's it? Definition and all this, right? So classification is the process. Classification is the process of arranging data into sequence and the groups according to their characteristics or separating them into the different but related parts. Right? That is the process of arranging data into the sequence and groups. So classification is the scheme for breaking a category into set of parts called the classes according to some precisely defined different characteristics possessed by all the elements of the category. So what we made in the classification, we made some columns or we say some classes, right? So classes is what? Classes like a categorical head. That means the elements in that category. So there's a classification emphasis upon the arrangement of the data into different classes, which are at the determined depending on the nature, objective, and the scope of the inquiry. For instance, the number of the students registered in Delhi University during the academic year 2002 and 3 may be classified on the basis of any of the following criteria. See, for example, if you take Delhi University students registered, the number of students in the DU, right? So they can be classified into the sex, age, the state which they belong, religion, different faculties like art, science, humanities, highlights or weights, institution, and so on like this. These are the different criteria, right? See, this means, for example, you have seen while registering in DU or any of the university, or you fill the form of your university, what you have mentioned, first of all, your name, then father's name, mother's name, your address, then this is next topic is like a sex, male or female, age, specify the age, what is the age of yours, right? 17, 18, 19, 21, whatever it is, right? The states which you belong. Similarly, religion, right? Like this. So at the end of the day, when you fill the form, right? Let me assume that you fill the form online, right? So what happened? They got the data. You fill the form, your name is this, your age is this, your father's name is this, your address is this, you belongs to this region, you belong to this state, you belong to this, your and everything, right? Okay, right? So Now, in this form, university can segregate that blah blah percentage of students are males, right? This percentage of students having the age of 21, right? And if this percentage of students belongs to Delhi, belongs to Haryana, belongs to UP, belongs to Bihar, belongs to West Bengal, and so on like this, right? So this is called a classification. These are the some kind of the fact. We classify into the different criteria. Thus, the same set of the data can be classified into the different scope, different groups of the classes in a number of ways based on any recognizable physical, social, or the mental characteristics which exhibits the variation among the different elements of the given data. The facts of one class will differ from those of another class with respect to some characteristics called the basis or criterion of classification. These are the bases of classification, right? As an illustration, the data relating to socio-economy inquiry, example, the family budget relating to the nature, quality, quantity of the commodities consumed by the group of people together with the expenditure on the different food items. These may be the classified in the following major heads. For example, food. For example, see in the socio-economic inquiry, any family budget, right? So most of the family budget, they spend on food, clothing, fuel and lighting, right? House rent and miscellaneous, like education. So what they form the 5 heads, right? So we can segregate that this percentage of people spend in, for example, low group income people spend this percentage on food, this percentage on clothing, this percentage on fuel and lighting in the house rent and the miscellaneous. Similarly, rich people spend this percentage. So we can easily segregate out, right? Each of the above groups and classes may further be divided into the subgroups. Like for example, food may be subdivided to the cereals, rice, this is vegetables, milk, all these things. So these are the what? These are the further classification of this. Right? Function of classification. Function of the classification may be the brief summarize as follows. It condenses the data, right? It condenses the data. Short kar deta hai, right? Classify the present data, the huge and widely raw data in a condensed form. Got it? Got it? Hello?
Yes, sir. Yes, sir. Continue. Hello.
Hello? Yes. Got it? Okay.
Yes, sir.
Facilitate.
सर
Yes.
सर यहाँ पे एक क्वेश्चन करूँ सर ये पार्ट ऑफ डेटा सर ऑर्डिनल नॉमिनल की पार्ट भी हो सकता है ना
सब हो सकता है
ओके सर
कुछ भी डेटा right any data we can any data we put when we put some groups or some rows or the columns that is a kind of classification or tabulation that we can arrange in systematical manner, right?
Okay.
It facilitates the comparisons. It helps to study the relationships. It facilitates the statistical treatment of the data, right? Now, rules for classification. Although classification is one of the most important technique for the statistical treatment and analysis of the numerical data, no hard and the fast tools can be the laid down for it. Obviously, a technically sound classification of the data in any statistical investigation will primarily depends on the nature of the data and objective of the inquiry. However, consistent with the nature and objective of the inquiry, the following general guiding principles may be observed for the good classification. Now, what are the good for the good classification of the principles? It should be the unambiguous. The classes should be the rigid, defined so that they should not lead to any ambiguity. Right? In other words, there should not be any room for doubts or the confusion regarding the placement of the observation in the given classes. For example, if we have to classify a group of individuals as employed or unemployed or literate or illiterate, it is imperative to define in the clear-cut term as by what means by the employed person or unemployed person. Right? It should be exhaustive and mutually exclusive. Classification must be the mutually exclusive. That means different. Mutually exhaustive. Sorry, exhaustive and exhaustive in the sense that every issued item in the data must be belong to one of the classes. Each and every terms or whatever must be belongs to class. A good classification should be the free from the residual class like the others or miscellaneous, because such classes do not reveal the characteristics of the data completely.
Sir, what is the meaning of mutually exclusive?
Mutually exclusive is different. That means one category or one class is different from the other class.
Oh.
We have classified the, for example, weight is different from
Age.
That's they are the different. So they are the mutually exclusive.
Oh.
And exhaustive means each and every classes. When we gathered all this thing, they, for example, for the individual, all the classes are, when we taken all this together, they all classes defined for that individual one, right? Each and every classes. It should be a stable. It should be a stable, right? That is in order of the meaningful comparison of the result, the ideal classification must be stable. Then it should be suitable for the purpose, right? So that means if we classify it, so we have some purpose to solve it. It should be flexible. Good classification should be the flexible in that it should be adjustable to the new and changed situation and conditions. No classification is a good enough to be the use forever. Changes here and there become necessary with the change of the time, right? So it should be flexible so that we can change according to our flexibility. Right? Basis of the classification. Basis of the criteria with the data that classified depends on the objective and the purpose of the inquiry. Generally, the data can be classified in the following four bases. Geographically, that is area region-wise, chronological, aspects of time, qualitative, some characters or attributes, or quantitative, numerical value. Right? First of all, the geographical classification. As the name suggests in the classification, this is geographical based on the location different on the various items, right? Like a city, this region, zones, this. For example, the yield of the agriculture output per hectare for the different countries is the same given distance with the population. This is given. For the example, is agriculture output of the different countries. So this is geographically classification. India, USA, Pakistan, all the geographically different. So this is the classification, right? Similarly, density of the population in the different cities. Similarly, chronological classification, that is number wise. Chronological means one of these the data classified into the basis that difference in time, right? Profit of the big business over the years. In journal, this is over the time period. 1901, 1911, this the population is this. So chronological means, see, this is a chronological order from less to more. Right? Qualitative classification. When the data are classified according to some qualitative phenomena, which are not capable of the quantitative measurement like honesty, beauty, employment, intelligence, occupation, sex, literacy, etc. The classification system is the qualitative or descriptive or with respect to attributes. So in qualitative classification, the data is classified according to the presence or absence of attributes in the given units. If the data are classified into the two classes with respect to an attribute like a presence or absence among the various units, the classification is a simple or mechanism. See, in what qualitative, we take the data according to some qualitative phenomena, right? Like honesty, beauty, like this. This is given. Classification now. More of the population is divided with the, this is the same thing. Our population is a quantitative classification. With the data, the classified in the basis of phenomena which are capable of the quantitative meaning like age, height, this. Right, the quantitative phenomena under the study is this. This quantity given. Earning up to this number of stored this. Earning up to this number of stored this. Right. So those who define some quantities, this is called the quantitative classification. Also variable. As already pointed out, the quantitative phenomena under the study, like a marks in a test, heights, weights of the students in the class, wages of the worker in a factory, sales in the departmental store. These are the variables. So variables are of two kinds, continuous variable or discrete variable. Right? Right? Those variables which can take all the possible values. Integral as the fraction given in the specified range. This is a quantitative. Those those variable that means which have some limits kind of thing. Limits kind of thing, that means some range is there. So when any variable is having the range, that is a continuous. Otherwise, it is a discrete.
If the age of a person, we have, if you take the height of the persons, it may be 47.5, it may be 48.70 centimeter, like that. So it will be a continuous variable.
See, I'll tell you one thing. See, this is what in this example, what you have seen, daily earning is up to 100, 101 to 200. So this kind of data is, this is comes as a continuous variable, because see, you told me that height is 47.3, 47.2, right? So there might be a number of variables. So they are differ by 0.1, 0.2 or 1 centimeter or 1.2 centimeter, right? So what we do, we find out the age, some some range, right? So some limit defined, that is from 101 to 200. Whatever the number in this, it's come in this category. That means 14 stores, right? So might be they are earning 101.5 or 195 or 148.6. Okay. So all these stores, those who are earning between 101 to 200, they comes in this category. So this kind of representation of data is called the continuous, right? If these are the variables, these are called the frequency. Now, these are the variables, whatever they told. So this is a continuous variable. If there is single number, for example, here it is written like 100, 200, 300, then that is called a discrete variable. Any question?
Sir, also blood pressure is also continuous variable.
Which one?
So blood pressure.
If the variable is single, hello. If the variable is single, that is called a discrete. Here is the range, that is a continuous.
Okay.
Okay.
Okay, sir.
Now, frequency distribution. Wait. Now, frequency distribution, right? So what is frequency distribution? The organizing of the data pertaining to its quantitative phenomenon involves the 4 stages. The set or series of individual observation, organized raw or organized array data, discrete or the ungrouped frequency distribution, grouped of frequency distribution, or continuous frequency distributions. We shall explain the various stages by the means of this numerical. Now, see this example. Let us consider the distribution marks of the 200 students in an examination arranged serially in the order of their roll numbers, right? See, marks of 200 students, given that 70, 45. For example, let me take with the roll number wise. Roll number 1 got 70, 2 got 45, roll number 30 got 33, 64, 50, and so on like this, right? The data in the above form is called the raw or the disorganized. In the raw form of the data, so unwidely and scattered that even after the very careful perusal, the various details contained there remain the unfollowed and the uncompensated. See, when you first look at this data, you cannot find any, you just see only the numbers that number 1 got this, 2 got this. You cannot interpret some detailed information from that.
No meaningful information.
No meaningful information. Right. So what we do, we arrange the data in that manner so that we can get some useful information from that. All right. So for the representation, the above data would be arrange them in the ascending or descending order of the magnitude, which is called the arraying of data. Right. Okay. Now, discrete to the ungrouped frequency distributions. A much better way of the representation of the data is to express it in the form of the discrete or ungrouped frequency, where we count the number of times each value of the variable marks of the above illustration, frequency of the above data. This is facilitated through the technique of the tally marks of the tally bars, right? We make a display. Right, we put some tally marks on this. See, for example, what we have done from the infection, we find out that the minimum marks is 15 and the maximum marks is 200 or 78 from this data, right? So what we have done, we write the number 15, 16, 17, 18 and up to 70, right? Okay. See. What we do, for example, the first roll number got the 70 marks, second roll number got 45 marks. Now 70 marks, right? First one entered the 70. So what we do in the 70, we make one bar, right? We put one bar. That means one entry. Second one is what? 45, then 33. So in the 45, we made one bar. In 33, we made one bar, and so on like this. So we made these bars. This is called the tally bars. So 1, 2, 3, 4. Fifth one, we cross this. See, 1, 2, 3, 4 in the 42. 1, 2, 3, 4. Fifth one is cross. That means this shows the single bundle of 5. Similarly, 5. This one is also 5. This is 4 lines. So 5 plus 5, 10 plus 4, 14. So the total number comes to be a 14. So that means 14 students got 42 marks. Right? Similarly, 8 students got 53 marks. 8 students got 38 marks. 9 students got 39 marks, and so on like this. This is called the frequency distribution table. Right? So in this, marks are the variable because this is very. So these are the single marks, you know, single number. So this is the discrete series. Group frequency distribution. So in the group, what we made some different classes with different intervals, right? Because it's very difficult to segregate data in this type. The different names, because how we can see what do you happen 63, 64, 65, then 67, because 60 after 65 we came to know that there is 67 marks of student, not a 66. So we write the 67 and like this. Okay, so but it's a very that this distribution become very large, and we are not get any information from that, because we get some information, but it's a very large, so it's very difficult to get the information from that. And obviously the calculation make more difficult because the table is huge, right? Okay. Now, so what we do, the next one is the frequency, group frequency distribution, right? Now, group frequency distribution, right? So in group distribution, we made some like groups like this, right? Marks, that is a for class intervals, the number of students in, right? For example, 15 to 19, we make first class, then 20 to 24, then 25 to 29, then 30. In the similar way, what we have done for this, for example, see.
This is said here, the group is, first group is 15 to 19. Now 15 to 19 means 15, 16, 17, 18, 19. So the interval is now on which basis we are going to make this interval.
Okay.
After that, because I see here 15 plus 4, 19. Then again 22, 24, 4. If I can take it, why I cannot take it 5? It will become 20. On which basis this this range is taken?
See, this is a group of 15, 16, 17, 18, and 19. 5. Right? So what we made, first of all, from the given data, we find out the range. Range is what? Maximum marks and minimum marks. 78 is the maximum, 15 is the minimum. This is called a range. We put out the range. Range comes to be a 63. Right? Now, your wish. You want size of 5 or size of 8 or size of 10. So what we do, we divide this range into whatever the you want, size 5 or 7 or 9 or 10 or 11 or 12, generally 5 or 8, 5 or 10, like this you can make. So 63 divided by 5, it comes to be 13. So approximately 13 groups. Or you can do vice versa. For example, you need 10 groups. You want to form 10 groups, right? So what you do, divide this difference range by whatever your wish. Your wish is 10 groups.
10. Yes.
Divide by 10. It comes to be 6.3.
6.
So your size must be a 6.3, right? So 6.3 is a very odd. So you estimate it to either 6 or 7. So groups comes to be a approximate groups comes to be a either 11 or 9 number of groups. So this we can do from our wish, whatever we do, right? In this classes, this is the first class, this is second class, third class, fourth class, and so on. This is first class. First class is, this is called a range, 15 to 19. This is a lower limit, 15 is a lower limit, 19 is the upper limit. So for the first class, the lower limit is 15 and the upper limit is 19. Similarly, the second one, lower limit is 20, upper limit is for the second class. Lower limit is 20 and then 20, right? Type of classes. The classes should be clearly defined, should not be written to the name pretty. They should be aggressive in the exclusive. Leave this. Sizes of the class intervals. Now, size of the class intervals. Since the size of the class interval is inversely proportional to the number of classes, I have told you, na, find out the range and then find out this, right? Read it. Read this one. type of class interval. Now, inclusive type or exclusive type, right? See, in this last example, what we have done, we made a term 15 to 19, then 20 to 24, and so on. Example 39, 49, 40 to 49. This is called the inclusive classes. In inclusive classes, we include both these numbers, 30 lower term, 39 upper term, right? Upper limit and lower limit. We include these two. So this is called the inclusive type. Now comes to the exclusive. What we have seen in the exclusive type, the interval is like this, 15 to 20. Then next one is 20 to 25. Next is 25 to 30, and so on like this. This is exclusive type, right? See, what we have seen, 20 comes 2 times. That means this is the upper limit of the first class and lower limit in second class. So lower limit, upper limit of class, whenever is the lower limit of its next class, then it is the exclusive type. So what we do in this case, see, in the first class there is 20, right? If any number comes to be 20, then it must be taken in second class. We exclude for the upper limit, right? If any numbers comes 20, for example, in the variable, we must take in this class. Is it clear? Is it clear?
Yeah, absolutely clear.
Read this one. See, sometimes we ask to change inclusive into exclusive form, right? So what we do, for example, see in the district. This is inclusive form. We change into exclusive. What we do, see what is the difference of this 24 and 25? Difference is 1. Difference is 1. We make correction factor, that is d by 2, half this, half of difference. Now in this case, difference is 1. We make it half by 2. It comes to be 0.5. So what we do, in the lower limit, subtract 0.5, upper limit, add 0.5. Lower limit, subtract 0.5, upper limit, add 0.5. If we subtract 0.5 from 20, it comes to be 19.5. Similarly, add 0.5, it comes to be 24.5. Now this limit 20 to 24 now become 19 to 24.5, 19.5 to 24.5. In the similar way, second, subtract 0.5 from lower, add 0.5 to upper, it becomes this. Now these comes to be in this exclusive. This is a change of inclusive into exclusive. Got it?
Yes, sir. Yes.
class mark or mid value. Formula for this is lower limit plus upper limit divided by 2. Lower limit plus upper limit divided by 2. It comes to 22. In this example, this 20 plus 24 divided by 2 is 22. Or in this way, 19.5 plus 24.5 divided by 2. Same. So class mark or say mid value both for these things. Right? Open end classes. Open end classes means if the lower limit of the first class or the upper limit of the last class is not specified. In that case, we say open end classes. For example, class like marks less than 20 or age above 60. These type of form is we say open end classes, right? These are some examples of frequency distribution.
First of all, we have to take the lower value and then we get the higher value and subtract it. We will get the range.
Range.
And accordingly, if you want, you can divide by 4.
Whatever the classes you want or intervals you want, right?
Yes.
See, the following table shows the distribution of the lifetime of the 350 radio tubes. Lifetime is given in number of tubes. Stating the clearly the assumption involved obtain the percentage of tubes that have the lifetime greater than 760 hours, between 650 and 850, less than 530 hours. Under the assumption that the classes frequency are the uniformly distributed within the corresponding classes, right? They are the uniformly distributed. The gap is 100 and 100. Now what we do? these type of questions, right? These type of questions. Bivariate frequency distribution. This is a bivariate frequency distribution. In bivariate, that means two variable, X variable and the Y variable, right? Similarly, classes this, and so on like this. So this is how we show this bivariate frequency, right? Very. I'm just giving you the idea of what is a bivariate. Now, second one is tabulation. Tabulation is table, like a table, right? We make some table in this. Statistical table is a logical listing of the related quantitative data in the vertical columns of the horizontal row of the numbers with a sufficient explanatory of the qualifying words. This is on the statement in the form of the titles, heading, and the notes in the to make the clear the meaningful full meaning of the data in their origin. Part of it. The various parts of the table vary from the problem depending on the nature of the data and the purpose of the investigation. However, the following must be the good statistical table. Table number, title, head notes, prefatory notes, captions, subs, body of the table, footnotes, source of the table. Like table number, we always make a number for that table, right? You've seen in this, in every book, when there is a table, for example, for this table, you mention a table 3.25. This is a table number, right? Similarly, caption is given, showing the marks of conditions and law instructions. Right. Table number. Then title, all it shows is the title. Head notes, or the whatever the notes you want. This. Similarly, caption or subs. What are the captions? Captions are heading of the this in the vertical columns of the subs, in the rows as well as the column. Then the body of the table. What do you want in that? Footnotes. Footnote is some characteristics feature of the items in the table which are not adequately explained. So we make asterisk marks and write down that this is blah blah blah. Right. So that is called a footnotes. That is the explanation for that particular category. Right? source node. What is the source of collecting the data? Right? This is some kind of a format of that. See, look at this. See in the details, everything. Okay. Type of tables. This is a type of table given. Let me do the example for that. This is the example of this. What is the table name? How they showing the different things. With this example. Present the following information the suitable development. So find the previous not given currently. In 1995, I had a total 2,000 workers. Let us see. Take 50 were the members of the trade unions. The number of women workers employed was 50 out of which 200 returned benefit. The number of trade union workers was 1725, of which 1600 were men. The number of non-trade union workers was 3. And the 155 were women. Now, please look carefully for this example, right? Now, this is kind of your first practical question, right? Start with this. Again, look the question carefully. In 95, see what we have seen in this. In this, we have seen workers in a factory, right? Some trade union is there. Some women, that means women and men are there, right? Trade union is the trade union and non-trade union. And similarly, male, female, and union non-union, right? And obviously the other for this is a comparison to the 2 years, and 1 year is 1995 and the other one is 2000, right? So this is in this we have mentioned that table 3.32. This is a table number. So this is a heading: comparative study of the membership between trade unions in a factory in 95 and 2000, right? So okay, we made a table like this here. Trade unions may one of the members and non-members of the trade union, right? So there are for the this is comparison of the 2 years. So we put it 2 years, 1995 and 2000. 1995 males, females, and the total similarly in 2000s in the similar way, right? Okay, this is the total. Total we have to write must be for forming this table total in this row and as well as in the total, right? As well as in the column, sorry. And this is first one for the 1985. Similarly, the similar way we made for the 2000, right? Okay, comes to be 1995. See, right? Now, what was the first figure? Out of total 2000 workers in a factory. That means the grand total 2000s are given. Total worker in a factory is 2000, including men, women, union, non-union, all these, right? So this is a grand total 2000 written. 2000. We assume that all are blank things, right? And we are now forming the table with these inputs, right? So total brand is 2000, right? Okay. 1550 are the members of trade union. See, in this total, look at this. In this total, if we see this column, in this column, this is a total of trade union members and this is non-trade union members, right? So, given 1550 are the members of trade union. So, in trade union, we write it 1550, right? Now we have total 2000. So, if we subtract 2000 minus 1550, we get 450. Obviously, 450 were the non-trade union members. Got it? Yes. Any doubt? Any doubt?
No, sir. Okay.
To all of you, please tell me.
Okay, sir. Okay.
Okay. Next point is the number of women workers employed was 250. Males and female given. Female are 250, right? If we subtract 2000 minus 250, we got male members total. So we got 1750 male members, right? In this, the number of women worker employed was 250, out of which 200 did not belong to any trade union. In this 250, 200 women did not belong to trade union. So in 250, 200 are non-members. So obviously when 250 minus 200, we got the trade union members. Got it? Is that clear?
Yes, yes.
Quite clear.
Okay. Then we get this point, this column. Now come to this first one. 1550 minus 50. If we subtract this, we got the male members. We got male members. In the similar way, 450 minus 200, we got the female non-members. That's it. Now this 95 table was complete.
Actually, what I find here that the figures which are given here, those things have to be firstly put into the respective spots of the column.
Yes, whatever the given in this inputs we
data.
have. Yes.
And the rest of the data that has to be calculated.
Yes. Yes. Right. In the similar way, say for the in 2000, for the 2000 years, right? The number of union worker was 1725. Number of union workers, right? So members total members, this is the members. So total members comes to be this. So this is 1725 total members. Got it? Of which 1600 were men. 1600 were men. So 1725 minus 1600 comes to be a 125. Got it? Is it clear?
Yes, sir. Got it.
Good. Now, the number of the non-union worker was 380. Non-union was 380. Non-members, given that non-members are 380. So this one is non-members, total of 380, right? Among which 155 are women. So 155 are women. So obviously 380 minus 155, we get to know this, we get the males number. Now all these six we have filled. 16 and now add this 1600 plus 225, we get total this. Similar way, female 125 plus 155, we get this. 1725 plus 380, we got this. Is that clear?
Yes, sir. Yes. Got it.
In similar with the second question. That is a similar way. Do this one. Do this 3.13. Please do. I'm waiting. Take one paper and pen. Make this table. This was the town A and town B. Do please. Are you doing?
Yes, sir. Yes, sir.
We are doing.
is completed.
So चल रहा है, थोड़ा टाइम लगेगा.
क्या क्या बोल रहे हो?
Sir, continue.
No, have you tried this question or not? Or shall I continue?
Yes, sir. Yes, sir.
So in this example, see, this is for the town A, this is for the town B, and they consolidated town and town B permission. See, in this town A, there are two things: coffee drinkers and the non-coffee drinkers. And the given question was in the percentage, so that obviously the total percentage is 100, so we make according to that. So for the town A, the females were 40%. Obviously, the females were 40%, and the males were 60%. So males and the female, this is 40%. Obviously, total is 100. Female is given 40%. Then with the help of this 40, we can calculate the 60, right? So we come to a total male is 60%. And what the other information given? The total coffee drinkers were 45. Total coffee drinkers were 45%. See, coffee drinkers total 45. Right. So obviously 100 minus 45, we got the 55. That is a non-coffee drinkers. So total coffee drinkers are 45, and the males, non-coffee drinkers were 20%. Males, non-coffee drinkers 20. And we already find the 60, so 60 minus 20 comes to be 40. So this we come to 40. Total we have, so 45 minus 40, we get 5. This, and because total is 45, so 100 minus 45, we get 55 this figure. So 20, 55 minus 20, we got this. That is same thing, 40 minus 5. In the similar way, what town B? Right? Is it clear?
Actually,
Yes, sir.
I
Yes, sir.
placed on the left side town A and town B, and then I gave a heading female and
Coffee drinkers and non-coffee drinkers.
females. Under
Yes.
each males and females, then I did a sub table, sub cell, coffee drinkers and non-coffee drinkers.
Yes.
It comes to the same thing.
Yes.
Yes, sir.
Is only that the value which has been given here, that has to be prepared at the appropriate cell, and the rate of the cell, the rest of the cells has to be calculated.
Absolutely. Absolutely.
Yes, yes.
Okay. So, got it, no?
Yes, sir. Yes, sir. Got it.
Okay. Diagrammatic and the graphical representations, right? So diagrams is what kind of we represent the data in the diagrammatical form, or so in some graph forms. This is diagram graph. So what are the number of advantages for these diagrams? So the graphs are the visual aids. So what happened when you see the diagrams of the graph, you can easily interpret the things, right? So are the visual aids for which they give the bird's eye view. That means you can easily, at the first chance, you can find out your interpretation, right? Diagrams are generally more attractive, fascinating, and impressive than the numerical data because you can obviously, if you want to see the data, so in the numbers as compared to diagrams, you prefer the diagrams because that is fascinating, impressive, right? Similarly, they are the more catching, such as the extensive use of the present set zero figures. They register meaningful impression on the mind almost before we think. When properly constructed, diagrams and the graphs readily now show the information that might otherwise be lost away. Graphs reveals the trends, if any person in the data more vivid than the tabulation. These are the few things why we use the graph.
The usefulness of the graph lies in the fact that it can be understood very easily by a common person also, which do not have any knowledge of statistics.
Very good. Yes, obviously. That is a more attractive. So you can easily, obviously, that is, you can easily interpret the data, right? Okay.
Sir, hello, sir.
Yes.
So these all are tools or procedure of data collection.
Yeah, this is a different topic diagram to the graph.
Okay.
Okay. Difference between the diagrams and the graphs. So there's no hard and fast rules exist to distinguish between these, but the following points may be the difference. In the construction of the graph, generally graph paper is used. See, leave this point. You just read it. Graph paper. In the graph paper, we can do the graph, and diagrams we can use in the plain paper. Diagram furnishes only the approximate information. They do not have any do not add anything meaningful to the data, right? But graphs have, because you do the graph by the rows and columns, you put some exact marks, the exact values, whatever the given in the data. Diagrams are the useful in the representing the categorical, the geographical data, but they fail to present the related to the time series in the frequency distribution. Right, so we cannot make the diagram for the time series or the frequency distribution. We make only the categorical geographical data. In fact, the graphs are the used for the study of the time series in the frequency distribution. Construction of the graphs is easier as compared to the construction of the graph diagrams, right? Diagrammatical representation. This is what is a diagram. And generally, diagram is one. We generate type of diagram: 1 dimension, 2 dimension, 3 dimension, pictograph or pattern. See, in this way, first of all, this line diagram. The following data shows the number of accidents sustained by the 314 drivers to the public utility company over the period of 5 years. Number of accidents, number of drivers. Represent the data by line diagram. Number of accidents. Obviously, the first part. First is number of accidents. Then second is number of drivers. So generally, the first one is x-axis. Second part is y-axis. Got it? So in this question, number of accidents 0 to 11. So we write it number of accidents 0 to 11. And number of drivers, minimum is 2. Maximum is 82. Right.
Sir, one example. In line diagram, growth chart is also present line diagram.
Come again.
And it's a growth chart.
Growth chart.
Yes, sir. According to height and weight.
See, growth chart is a different. That's we show in growth. That is a chart. That is a different from this. That is a not diagram. We can consider that in the graph, because if you make a graph, then you came to know that what the exact growth is happening, how much percentage of, right? So we do that by the figures. So in the line, see, in the line diagrams, we only show the line. See, number of accidents up to this 82. First mark is up to 82. Zero accident, 82 drivers. One accident, 44 drivers. Similarly, 2 accidents, 68 drivers, and so on like this. Got it?
Okay.
Okay. Bar diagram. The second one is bar diagram. Only line diagram and the bar diagram. These two things are the important. Let me do with the bar diagram. This is important things, because generally they can ask the bar diagram also, right? So what is a bar diagram? Bar diagram is indeed what that is a kind of we made some rectangular things over there, right? All the bars drawn in the single study should be the uniform. Proper, but the uniform spacing should be given in the different bars to make the diagram look more attractive and elegant. The height and the length of the rectangles of the bars are taken proportionate to the magnitude of the divisions. All the bars should be constructed in the same line. It is desirable to write the figures represented with the bars. Bars may be drawn up vertically or horizontally. Whenever possible, the bars should be arranged from the left to right. This is bar diagram. See, following type of bar diagram. Simple bar diagram, subdivided or component bar diagram, percentage bar diagram, multiple bar diagram, a division or piloted bar diagram. Right? Simple bar diagram. Simple bar diagram is the simplest of the bar diagram and used frequency in the practices. For the competitive study of the two or more items to the value of the single. For example, the data related to the sales, profit, productions, populations, for the different periods. The following data related to the strength of the Indian merchant shipping fleet gives the gross registered tonnages GRT on the 31st December for the following years. In the 1961, the GRT in the thousands is 901, in 66 is this, 71 is this, and so on like this, right? So they mentioned their sources in Ministry of Shipping Transport during the time. Suitable bar diagram. Now, what is a bar diagram? In this bar, what we made, the first column is like here. The first column is here. We made this is a x-axis. This we make a x-axis. The second one is GRT. We make it the y-axis, right? What is given in the 61 data is given. Then 66 after 5 years. Then in 77 after 5 years. Then in 75 after 4 years. Then the next year it is the data. Right? We make this line, right? This show that this is continue. So we have started from this. So that's why we make this like a king or this line, right? 61. Then obviously for the gap of 5 years, we make some distance, 66 and 71, 5 years, obviously. Then 4 years, we make little less. Then obviously for the next years, we make 76, right? Now what is happening? The first one is 901. We made this in the Y column. 1500 with a gap of 1500. We make this. The first one is 901. We make this some approximate value of this because we are drawing by the paper and pen. So this is the approximate value 901. Obviously 900 near 900. We make this in the graph. Obviously we can do in the graph also. So we make a box on this. We make a box. For the second 1792. The next one is 2500. The next one is this. We make this. So in general, what we made a rectangle for each year, for each data, for the each GRT. So this is called a bar. Got it? Got it? Clear है बेटा?
Sir, continue, sir.
Now subdivided the component of the bar diagrams. Subdivided. We further divide the data into much more. Let me take an example for this. This is given, right? So use a subdivided bar diagram in this. They only represent the data in the suitable diagram. That is, see, given is list of expenditures, family A, family B. Income is 500, income is 300. Obviously, with the help of 500, they spend this. 300, we spend this. Right? Now, we make a rectangle of 500 because the income is 500. If we add this 150, 125, 25, 150, 300, 300 and 200, 500. Income is comes to 500. 150, 60, 210, 210 plus 50, 260, 260 plus 70, 330. Right? Income is 300, right? So what we make up to 300 and 13 below this line, right? Income is 500, income is 300. We make this rectangle of family A and family B. Now, first of all, food 150. So from 500, 150, 100, then this 150. We make a point, we draw this. Right? This in the similar way, this food 150. We make some for the recognition, we shade this in some pattern. Obviously, then for the clothing 125, from this point, we count the 125 below this line, 125. In the similar way here, 60. We make the different shade in this, show that this is clothing. You can also write this clothing. Then below 5 and the 50 below this line, education is 25. And this one is a 50, right? We make some different pattern shade. Then miscellaneous 190 and 70, we make a different shade. Then obviously saving and deficits, which comes with this. And in this case, we made below this.
सर यहाँ पे ऑल डाटा को लेके जस्ट एक डायग्राम करना है, यही तो?
हाँ, डायग्राम करना है. हमने क्या किया, एक सिंगल डायग्राम को we subdivided that diagram. हमने एक डायग्राम बनाया. For example, for the family A, we made this one, right? For the family A,
yes, yes.
we made this one. So इसी बार को we subdivided into it, further divided into this. right?
Okay, sir. Okay.
So this is
Okay,
kind of a bar diagram for the two families, family A and the family B, whose income is 500, whose income is 300, right? We show them in the bar diagram.
Yes, sir.
Further, he says that for the family A, is segregated in the food, the clothing, education, miscellaneous, whatever it is. So we further subdivide. Got it?
Sir, easily see the matter, just what happened.
Come again. What? What?
Hello.
Yes. What are you saying? दोबारा बोलो.
सर मैं बोल रहा हूँ एक्चुअली ये डायग्राम को देख के इजीली पता चलेगा क्या हो रहा है, कैसे हो रहा है.
Right. Next percentage bar diagrams. This is expenditure given. We have to draw the percentage bar diagram, right? So we have to find the percentage for that. So how we calculate the percentage? This is data is given. This is data, right? This data is given. So we make a percentage of this. So total comes to be a 720. Total is 720. So we make a percentage for the each and every category. The first one is food. We total is 720. So we make a percentage. Percentage is 240 divided by 720 into 100. We got this percentage. Right? Similar way, clothing. 66 divided by 720 into 100. These are the percentage expenditure, right? Now, with the help of this percentage, we find that this cumulative percentage. Cumulative percentage is what? 33.33 as it is. Then add 33.33 with 9.17. Add these one. Comes to be a 42.75. 42.5 plus 17.36, 59.86. 59.86 into plus 7.92. Get this. Similarly, this plus this comes to be this 73.61 plus this comes to, so it comes to be 100%. Right? So in general, what we do in expenditure, we divided expenditure into kind of 100 parts and we subdivided that 100 to show how much they spend on food, clothing, rent, fuel, education, or miscellaneous, right? See, what we made a rectangle. We made a rectangle of the 100, right? Now, first one is the food. Percentage is a 33.3, right? So see the cumulative, because it is easy to draw from the cumulative percentage, right? From the below this food, 33. So in the 33, we mark wherever the 33 showing, right? So in the 33, we make a line, and in this example, he just fill up this with a black. So this shows the food, that is 33.3, right? So the next one is the clothing, right? The cumulative is 42.5. So what we do from this percentage, because we have divided into this 100. The next one is 42.5. We put 42.5 somewhere here above this 42.5. We make again a line, right? We shade in the different pattern. It's showing that the clothing, we spent 19.17 on the clothing. Right? Now, the next one is the rent, right? In the cumulative, we find the next one is 59.86, right? The further 59.86, that is near to this 60. We make a line again, fill this different pattern on this rectangle. This come to the rent. Rent is how much? 17.36. So obviously this one is 17.36. In the similar way, we fill this rectangle. Got it?
Yes, sir. सर यहाँ पे फूड ब्लैक क्यों?
वो शेड पैटर्न वो किया बस एक different pattern जो fill करना है. That is only to
Okay.
You can fill in any way, either black with a color, or you can some
Yes, sir. Yes, sir. Okay.
head, whatever, right? Okay.
Okay.
Multiple bar diagrams. Multiple bar diagram is if the bar diagram is more than 2. See in this data, right? In 1994-95, company A has a profit this, company B is profit this. Similarly, in the 1996, company is profit B this, and so on for this. Now, because we have multiple for the single year, we have 2 data. For the single year, for the x-axis, we have 2 y-axis, मतलब 2 data आ गए, right? So what we do, एक x-axis पे हमने ये लिख दिया for the first one, right? In the y-axis, we made IS is 175, right? And the lowest is 90. So obviously 90 to 95. So we have make this 200. Okay. See for the company A 120 in 1994 it's a 120 पर एक rectangle बना देंगे, right? So obviously for the company B it's a 90. So in the similar way we make a 90, right? So for the company A we put the blank and for the company B we make a H line so to show the difference between these. In the similar way we make the diagram for the 95, 96, then 96 for 97 and so on like this. Okay, this is multiple.
If there would have been 3 companies, then 3 bar diagrams were there.
Right. Got it? The next one is division bars. Division bar is what we show the divisions. Divisions means the difference, right? So in this example, they are showing the exports and the imports, right? So divisions mean difference. So we find the difference. Difference is export minus import. So this is given. If the export is more than import, then the positive value. If the import is more, then it goes with negative value, right? No, show the bar diagram. We make this line for the year for the first data 94, 95 these data, right? And division comes to this. For the this 94 is 15. For the 94 is 15. For the next 95 it's a 23. Then minus a minus shade below this line. Minus 10 below this line. Minus 53 below this line. Right? So this show the division. What the divisions are happening in this data. The above, if the bar diagram is above this line, so it shows that the import is export is more, and obviously for the this show the import is export is low. Got it? Broken lines. Broken line is what? If the data is too, it's very high for the sub-specific case. It's a very high, na? So we can't plot in this. So what we do, we write it this, the number is 1270 and we make a line broken and show that this is extended part up to this. That's it. Got it? Like this, no? This is 700 is too much. So they show the proper line that is it's up to 7. Got it?
Yes, sir. I got it. Got it.
Okay, fine. So we do today up to this 2 diagrams.
These things can be now plotted in Excel sheet and we can get a graph.
Get a graph. Probably you got the graph, or you have to draw in this sheet, plain sheet.
Sir,
Yes.
sir, ये all diagrams and graphs only sir presentation purpose.
अभी प्रेजेंटेशन अभी और भी है, ग्राफ अभी है, नेक्स्ट क्लास में करेंगे, मैं अभी एक्सप्लेन.
Okay.
ठीक है.
Okay.
सिर्फ नेक्स्ट में मैं फिर, right?
Okay, sir.
Okay.
Okay.